For number 24, we need to know all of the chops for these, so I'll just do them in order. A circle is a chop parallel to the base. An ellipse is a chop diagonal to the base in one side, out the other. A hyperbola is a chop that is perpendicular to the bottom and it goes through both cones. And the parabola chop goes in one side and out either the bottom or the top. So remember how to do all four of those for the exam. This one wants to know which one slices the cone parallel to the base, and that was the first one I talked about. Parallel to the base is a circle. For number 25, we need to use our graphing calculator and the trig functions to figure out what theta equals. We want to know what the angle is. And whenever we need to work backwards to find theta, you need to do the inverse. So on your calculator, making sure you're in degree mode, type sine inverse of 0.75 and round it to the nearest tenth, and you will get about 48.6. Again, make sure you're in degree mode. If you're not, just type the mode button. It's right next to the second button. For number 26, we have the results of spins on a spinner. We want the probability that it did not land on green. That means it landed on red or blue. So 11 plus 10 means 21 of the spins did not land on green. How many total spins were there? Well, then we have to add up all the numbers. There's 33 total spins. So all you need to do is make sure that fraction is reduced as much as possible. It looks like we can divide both of these by 3, so 7/11ths would be your final answer here. In number 27, we have a bag with 5 black ribbons and 10 green ribbons. So first I'm thinking, how many ribbons are in the bag total? At the beginning of this, there's 15 total. Lila is going to select a ribbon, and then Jessica is going to select one from the remaining ribbons. That means after the first time a ribbon has been taken out, there won't be 15 in the bag anymore. There's only going to be 14. So we want the probability that Lila selects a black one first, so we know there's 5 black ones in the bag first, and then Jessica selects a green one. The word and means we're going to multiply. There's 10 green, so our job is to multiply these together. 5 times 10 is 50. On the bottom, 15 times 14 is 210. And then we reduce it to 5/21. For number 28, we need to take this little data set and find the mean and standard deviation. Mean is not difficult to calculate by hand. Standard deviation is a little more involved. So my recommendation is to put this data set in the calculator, which means you'll press Stat and then Edit. Enter those numbers in L1. Remember, if L1 has numbers in it, press Clear Enter when you're highlighting L1 and it'll get rid of all of them. So once you have them typed in L1, you press Stat, over to Calc, and Option 1, which is one variable stats. Once you hit Enter and the info comes up on your screen, the mean is X bar, and the standard deviation is sigma x. So when you just round them to the nearest tenths, the mean is about 4.2, and the standard deviation is about 3.19. For number 29, you're also going to input this data in the list 1, and then you can press Stat Calc 1, and you can just scroll down to get the 5-number summary that you need. If you prefer to do this by hand, you can order those from low to high, find the lowest number, the highest number, the middle number. Q1 is the middle of the lower half and Q3 is the middle of the upper half. But if you're just looking at the calculator screen for those numbers, you'll get 6, 7, 11, 14, and 15. So that's what we're going to plot on the graph. If we label our graph, all we need to do is plot each number. So 6, 7, 11, 14, and 15. And remember, the box always goes between Q1 and Q3. The median's in the middle of the box, and the min and the max are the whiskers. You can also press Zoom 9, making sure that plot 1 is turned on your calculator if you would like to see a picture of that on the screen. Remember, for normal functions, to see if a graph is a function, you use the VLT. While for inverses being functions, we use the HLT, the horizontal line test. So we draw a horizontal line through the graph anywhere, and as long as it only crosses it one time, it passes, and the inverse of the function will be a function. So we will say yes. This is a function because it passes the HLT. Here's an example of a graph that fails the HLT. See that circle? It goes through more than once. That's failing the HLT. All right, number 31. We are going to figure out whether this equation and that second equation, f and g, are inverses of each other. It says to use compositions, so that means we are going to plug the g function into the f function. So if the g function's green, we're going to plug that in to the x spot in the f function. So this will look like 1/7, and then instead of writing x, we're going to write 7x minus 28, and then we'll keep writing the rest of that f function plus 4. So we distribute the 1/7 to simplify this. So 1/7 of 7x is just 1x. 1/7 of negative 28, in other words, negative 28 divided by 7, is negative 4. And then we have plus 4. So those two cancel out, and we get x. Because we composed them and got x, we are kind of halfway there to deciding we need to figure out if when we compose it the other way, if we get x as well. So we're going to plug the f function into the g function. So here's what that'll look like. We'll take the 7, and then we're going to take the blue function, all of that, and we're going to put it right there for x. So we're going to plug in 1/7 x plus 4. And then we'll finish copying the rest of the g function. Go ahead and distribute. 7 times 1/7 is 1, so 1x. 7 times positive 4 is positive 28. Then we have minus 28, which means the 28's cancel out. And when we compose it that way, we also get x. Because both compositions equaled x, our answer here is yes. Those are inverses of each other. For number 32, we want to take the f function and the g function, and these are the directions right here. It's telling us we need to subtract them. So I'm just going to write it like a stacked up addition or subtraction problem. I'm going to keep that f function right there, and I'm going to put a big minus sign and write the negative 10x underneath the 7x, because those are like terms. And I'm going to write the plus 5 underneath the minus 3, because those are like terms. And I'm just going to do one big subtraction problem. So what's 5x squared minus no other x squareds? 5x squared. What's 7x minus negative 10x? Well, minus a negative means plus, so that means it's really like 7 plus 10. So it'll be 17x. And then we'll have negative 3 minus 5, and that's negative 8. For number 33, we need to multiply these two functions together. How do I know we're multiplying? Because it says f and g right next to each other. So since we're going to take something that's 3 terms and multiply it by something that's 2 terms, I'm going to draw a box that's 3 by 2. So I'll fill in the 8x squared, the 5x, and the minus 3. I'll put the negative 7x and the positive 6 on the side. Now I'm going to go through and multiply. Remember to multiply the coefficients, the big numbers, and add the exponents. So negative 7 times 8 is negative 56. X to the second times x to the first is x to the third. Negative 7 times 5 is 35. And x to the first times x to the first is x to the second. Negative 7 times negative 3 is positive 21 with that x. And now for the bottom row, 6 times 8 is 48 with an x squared. 6 times 5 is 30 with an x. And 6 times negative 3 is negative 18. Now I go through and look for like terms. Usually they appear on the diagonals. So to go in standard form with the highest exponent first, I'll put the negative 56x to the third first, and there are no other x to the thirds. But then when I look for the x to the seconds, I notice there's 48 and negative, I hope you caught me there, that should have been negative 35. 48 and negative 35, so when you subtract those, you get 13. 48 minus 35 is 13x squareds. And now the x's are on the diagonal there. There's 30 plus 21 more, so that's 51 x's, and then the minus 18 goes at the end. Number 34, we're going to draw a hyperbola. That's the thing where we have to draw a box, put the x's through it, and then draw the swoops one way or the other. So the first thing we get to do is find the center. So we're going to flip the sign by the x, so it's going to be negative 2. Flip the sign by the y, so it will be positive 1. And we'll plot that on the graph, negative 2, positive 1. Next, we square root the number underneath the y. So the square root of 25 is plus or minus 5. And because it's under the y, that means we're going to move up 5 and down 5. We will square root the 9, which is plus or minus 3. And since that's underneath the x, and the x-axis is horizontal, that means we're going to count left and right. 3 and 3. So we'll go up 5, 1, 2, 3, 4, 5. Down 5, 1, 2, 3, 4, 5. To the right 3 and left 3. And because this is a hyperbola, we are going to connect those with a rectangle. Put dashed lines through the corners. Those are our asymptotes. And now we need to decide if it's going to be horizontal or vertical. Remember, horizontal hyperbolas open like that. Vertical hyperbolas open like that. We know which way it opens by whichever letter comes first. Because y is first, this is going to be vertical. So we go to that top vertex and draw the hyperbola right there. Go to the bottom vertex, draw the hyperbola right there, and make sure you don't cross over those asymptotes. Number 35, unfortunately, does not match up with the way we normally see the equations for conic sections when we are going to graph them. So what we get to use is the formula b squared minus 4ac. It was in the very last section in the conic section chapter, and you have that little table at the bottom of the formula sheet. So we identify a, b, and c. When you look at the equation, a is always the number in front of x squared. So in this problem, a is 6. b is always the number in front of xy. So there's xy. The number in front of it would be a 1. C is always the number in front of y squared. If you don't have an x squared, an xy, or a y, it means that that term is going to be 0. So we take a, b, and c, plug them into b squared minus 4ac. So it's going to be 1 squared minus 4 times 6 times negative 3. Well, 1 squared is 1. Negative 4 times 6 is negative 24, and negative 24 times negative 3 is positive 72. So 1 plus 72 is 73. Because we have a positive number for our answer, we look at the chart, and when b squared minus 4ac is positive, when it's greater than 0, it says that the shape is a hyperbola. Another kind of quick way to figure it out is because you have both an x squared and a y squared, and there's a minus sign in front of that y squared, the hyperbola equations are the ones that have minus signs in between the x squared and y squared. So, number 36. We're going to use a trig function to find the value of x. Well, we have this angle is 45. We have the hypotenuse of the triangle is 40. And we want this side, which is opposite of our angle. Which trig function uses O and H? Sine does. So we have sine 45 equals our opposite side, which we don't know. We're calling it x, over the hypotenuse, which is 40. So you could grab your calculator and type sine 45, but sine 45 is a special angle. We know the exact value of sine 45 is the square root of 2 over 2. You will be given a unit circle on the exam that is totally filled out, so you don't have to find that. You could just go to 45 degrees and copy down the y value. It's the square root of 2 over 2. So you replace it, and now we get to cross multiply. So this will be 2 times x, which is 2x. 40 times the square root of 2 is 40 square root of 2. Divide both sides by 2 to get x by itself. And when you divide 40 by 2, you get 20. And then the square root of 2 stays next to it. Number 37, before we can find the values of the 6 trig functions, which use the opposite, adjacent, and hypotenuse, we need to actually find the hypotenuse, which is always c. That means the other 2 sides are a and b. It doesn't really matter which one's which, but if we have 2 sides and we want a third side, we use the Pythagorean theorem. So we'll plug in what we have. We'll have 18 squared plus 24 squared equals the hypotenuse squared. So 18 squared is 324. 24 squared is 576. So when we add those two together, you get 900 equals c squared. And then we'll square root both sides, and we get c equals 30, which seems reasonable in this problem. The number 30 seems to fit. So now we do have all of the sides, and what I'm going to do is from the angle theta that they labeled, I'm going to label O, A, and H. So across from the right angle is always the hypotenuse. Opposite our angle is going to be the 18. So that's our opposite side, and adjacent to that 24, or adjacent to the angle, is 24. Now that we have O, A, and H labeled, we just have to write down all of the ratios. So we'll write down SOHCAHTOA, and all this info will still be on the board during your exam. So we'll write down sine. Sine is going to be the opposite side, so 18, sine theta will be 18 over the hypotenuse, which is 30, and then we need to reduce it. So divide them both by 6, and we get 3/5. Cosine of theta will be the adjacent, so 24 over 30. Divide both of those by 6, and we get 4/5. Tangent theta will be opposite on top of adjacent, so 18 on top of 24. Divide both of those by 6, and we get 3/4. To get the remaining 3 trig functions, they're the reciprocals. We're just going to flip all those fractions over. So the reciprocal of sine is cosecant. So cosecant theta will be 5/3. Just flip the 3/5 over. The reciprocal of cosine is secant. So we'll flip the 4/5 over and get 5/4. The reciprocal of tangent is cotangent. So we'll flip the 3/4 over and get 4/3. For number 38, we're going to need to draw a picture. We have an angle of ascent and how high an airplane is off the ground. So you're off to a good start if you start by drawing a right triangle and then label it. So since it says our angle of ascent is 20 degrees, that means from the ground up, that number is 20 degrees. The airplane climbs to an altitude, that means how high you are off the ground, of 12,000 feet. So your height from the ground up right here is 12,000. At that point, it wants to know what the distance on land is between the airplane, which is right up here, and the airport, where it took off. So we're trying to figure out the distance on land. So that would be this horizontal part right here. So we label that as our x. And now we just go ahead and use SOHCAHTOA to figure out the side we're missing. Since 20 is our angle, the side right here is the opposite, and the side right here is the adjacent. Which trig function uses O and A? Tangent, because of TOA. So we have tan 20 equals the opposite side, 12,000, divided by x. There's nothing special about the angle 20 degrees, so you just grab your calculator, make sure it's in degree mode, type tan 20, round it to the 4th decimal place, so it's about 0.3639, set it equal to 12,000 over x, and then if I were you, I would put a 1 underneath that and cross multiply. So that means you would get 0.3639x, when you do x times that, equals 12,000. Since you want to get x alone, you'll divide both sides by 0.3639, divide by 0.3639, and you get x is approximately 32,976 feet. Angles that are coterminal just end in the same place. Like you guys know, 0 and 360 are coterminal. So if we have an angle 71 degrees, all we need to do is figure out another number that's in that same spot. So we can take 71 and go all the way around the circle again, which means we'll add 360 to it. So 71 plus 360 is 431 degrees. That'd be one answer. It's positive. Another way we could get to this spot is to start here and go around the graph backwards. So that means we would take 71 and subtract 360. Subtract a full circle. So 71 minus 360 is negative 289. The reference angle is the acute supplement to the x-axis. So what does that mean? Well, if you have an angle like 150 degrees, it means we don't want that big obtuse angle. We want this part, the acute part. So since right there the x-axis is 180 degrees, if you take 180 and subtract 150, you'll get 30 degrees. 180 minus 150. On the exam, you will get the conversion formulas for these, but I like to think about not using the formulas. I see a pi, and I know degrees don't have pi as part of the answer, so I'm going to divide by pi, which means I'm going to multiply on top by 180. So if you do 5 times 180, 5 times 180 on top, you get 900. And then when you divide that by, oops, I should have written a 6 right there, When you divide that by 6, you get 150 degrees. For number 42, we can use a reference angle, or you can just look on your unit circle because you will be given a unit circle on the exam. For cosine of 150, I know the reference angle for 150 is 30 degrees. So if I think about the hand trick for cosine of 30 degrees, I know the answer is the square root of 3 over 2. Or if you're looking on the unit circle at 150 degrees, you'll see the ordered pair. Cosine is what's in the x spot. Remember, cosine is x and sine is y. So we just want the cosine value, and if you look on your unit circle, you'll see it's negative square root 3 over 2, because x's are negative in the second quadrant. Last, we will find the exact value of cosine of 30. And we actually just were talking about it. If you look right on your unit circle, or if you use the hand trick, cosine of 30, when it's in the first quadrant, is positive square root 3 over 2.